So here I finished solving this problem where I've found my absolute min and max. Um, it doesn't ask for this, but we're going to do the second derivative to just check the concavity. And this is a lot of work to do the second derivative for this problem though. So f prime, double prime of x, when I apply that to this original derivative, so first of all, I'm just going to put the 2 on the outside. I don't really need to involve that in the derivative. I'm going to differentiate the numerator, so I get negative 2x, and then I'm going to multiply by the denominator, square root 16 minus x squared, okay, and then do the other part of the product rule, sorry, the quotient rule is going to be 8 minus x squared times the derivative of the denominator. Now the denominator is a bit of a messy derivative. We're going to get 1 over, we're going to differentiate the square root first. Okay, and then I'm going to multiply by the derivative of the inside, which is 2x. And then, oh, sorry, this is a 2 here. And then I need to make sure that I've got the denominator, so I need to divide by the root of x minus 16 minus x squared, and then we're going to square all that. Okay, so that's a pretty messy looking denominator as is. Oh, sorry, that's a messy looking second derivative. So I need to simplify this out a little bit. To do this, I'm first of all going to get rid of that and that and that and that. I need to make sure I combine into a positive. Okay, so I'm going to write this out. So I have 2 in the numerator. I end up with negative 2x square root 16 minus x squared. Okay, this is going to be plus, and then I'm going to end up with 8 minus x squared times, that's a square, times x. Okay, and in this denominator is square root 16 minus x squared. Okay, and then in the whole denominator, I end up with 16 minus x squared. Okay, so I can multiply the top and bottom of this expression, okay, this expression here, and to get a common denominator. And you'll see that, again, the square roots cancel out, so I'm going to multiply the top of this by 16 minus x squared. I'm going to multiply bottom of this by square root 16 minus x squared. Okay, and then simplifying this expression, I end up with 2, negative 2x. I better make sure I'm doing this neatly, otherwise it's really easy to lose track of things. So negative 2x times 16 minus x squared plus 8x minus x cubed. Okay, and then I'm just going to put this all under one denominator now. It's going to be 16 minus x squared times the square root of 16 minus x squared. Now I could put that all as a rational power as well if I want. In fact, I'll do that in the next step. So 2 times negative 32, it looks like. So I'm going to end up with, it looks like here, 2 times, so that's going to be 32x, okay, and then plus 2x cubed, just making sure of my signs here, plus 8x minus x cubed, and that's all over the denominator of 16 minus x squared, all to the power of 3 over 2. Combining some like terms, I end up with, looks like x cubed minus 24x. Okay, and then I'm going to factor the x out of that, and then I can evaluate my second derivative. So this works out to be 2 x squared minus 24. Okay, so the this here, sorry, it's going to be minus. So let's evaluate this second derivative. This is equal to 0 at x equals 0 and x equals plus minus square root 24. Now this plus minus square root 24 is actually outside of the domain of this function. So what we can do is we can ignore that because that's extraneous. Okay, it's extraneous to the problem. And I'm just going to put in my second derivative equal to 0 at 0, and then testing my concavity, f double prime. A good number to plug in maybe is going to be 1, so f double prime at 1. When I plug 1 into this, I'm going to end up with positive, positive 2, and then I'm going to end up with negative 23. And then the denominator, I'm going to end up with a positive number, so that's going to give us, looks like negative concavity in that region. So on the positive side, positive 1, I'm going to end up with negative concavity. And that kind of confirms what I already see there. This is why we didn't really need to do the second derivative, because we can kind of see that it changes concavity at the origin anyways. So I'm going to do the same thing here. I'm going to plug that in. So I'm going to get negative 2, and this is going to be negative 1 plugged in there into the brackets. Square brackets going to give me negative, and again, the denominator is positive. So that's going to give me a positive second derivative. And I can see from my graph again that that positive concavity is what I see in my derivative, or sorry, my slope charts. Okay, so that's just the second derivative. Again, that's just an extra, and it doesn't really give us any more information. That's why we really didn't need to do this. But there's the steps to getting the second derivative, and that's how we analyze that second derivative.